Hello everyone, welcome to the next lecture on the single value decompositions. In this lecture, I will explain you with the help of the numerical examples how you can decompose any matrix into the single value decomposition. Myself Dr. Harish, you can follow and subscribe my YouTube channel. What is the examples we have discussed in this lecture? We will cover all those metrics which are related to the n cross n, like you can see on the left side, while the middle and the right hand side you can see these are of order m cross n matrix. How you can write any matrix A into the single value decompositions, that we will see in this lecture. The concept, theory and all these notations, properties we have described in the concept of single value decomposition in my last lecture. You must watch and understand the concept of the single value decomposition. In this lecture, we will cover all those questions which are related to the square matrix. Like you can see all these 11 exercise, 2 cross 2, 2 cross 2, this is my 3 cross 3. How we can solve these problems in this lecture. Now I quickly recall the summary. Your target is to write any matrix A into the 3 matrix where U, sigma and V, where U is my orthogonal matrix. U is my orthogonal matrix. V is also known as the orthogonal matrix and sigma is called as the singular matrix. Fine. But make sure how you can find that. That's very simple. U is my orthogonal matrix, V is my orthogonal matrix, sigma is a matrix which are based on the singular value, and the notations is sigma I, which we have computed is positive square root of the lambda I. I will explain you with the help of the several examples in this lecture. But before that, let's quickly recall the procedure that I had explained in the concept of the single value decomposition. पहले आप इस lecture को सुनिएगा तो आपको पूरी थ्योरी प्रॉपर्टी समझ में आ जाएगी. I will explain you with the help of the 4th step. Fine. And these 4 steps are very simple. Fine. कोई भी example हो, you can solve to write any matrix A into the single value decomposition based on these 4 matrices. The step number 1 is your target is to compute the value of the A into A transpose and A transpose into A. Fine. Always remember these two matrices are always symmetric. For any matrix A, A into A transpose and A transpose A is always symmetric. Step number 2 is your target is to find the eigenvalues of A into A transpose. Fine. Mostly this matrix is also known as Gram matrix. ये सब थ्योरी मैंने आपको previous lecture में explain कर चुका हूं. Fine. So you must watch these lectures. Find the eigenvalues of the A into A transpose. So let's say lambda I are the eigenvalues of the A into A transpose. Fine. Once you know the eigenvalues of the A into A transpose, we can find the value of the sigma I, which is defined as positive square root of lambda I. And this sigma I is known as singular values. Fine. Once we know the sigma values, then we can firstly find the value of the sigma, which is defined as sigma 1, sigma 2, all are my diagonal values, rest values are my 0. Fine. Then we can write the sigma is a collection of all those sigmas in the diagonal, rest values are 0. Step number 3, we can compute the values of the V. V is also known as left singular matrix. Fine. V is also known as the left singular matrix. And the value, how you can compute them? By using the eigenvectors of A transpose A. Or you can also find in the step number 3 is U. You can firstly find as a U instead of the V, where UIs are the eigens vectors of A into A transpose. Fine. A into A. Choice is on your side. And the step number 4 is if you calculate the V firstly, then you can find the value of the U directly by using 1 over sigma I A into Vi. On the other hand, if in the step number 3 you calculate my as a U, fine, then you can calculate the value of the V is 1 over sigma I. Here is instead of the A, it is my A transpose of UI. Choice आपकी है, आप किसी भी तरह से कर सकते हो. मैं इस वीडियो में आपको दोनों मेथड से करके दिखाऊंगा. Fine. So now let's start with the numerical examples. But I hope before I start this, you can like and comment on this video. If you are new to my YouTube video, you can subscribe my YouTube channel as well. So let's start with the first example. So remember, your target is to write the matrix A into U sigma V transpose. This is your target. Fine. Now the question arises is, what are the sizes of these matrix? Fine. So in general, if A is your M cross N matrix, then the matrix U is my M cross M matrix. V matrix is my N cross N matrix. And the sigma matrix is my M cross N matrix. Fine. ये समझ में आ गया. Then for this particular example, can you find the size of the matrix U? Remember, this is my 2 cross 2 matrix. U is my 2 cross 2 matrix. V is my 2 cross 2 matrix. Sigma is my 2 cross 2 matrix. Is it okay up to here? Now, let's start with the step number 1. What is the step number 1 is, your target is to compute the value of A into A transpose and A transpose into A. So can you find the value of the A into A transpose? This is 1, 2, 1 and 2. So find the transpose 1, 2, 2, 1. So if you multiply them, 1 plus 4 is 5, 2 plus 2 is 4, 2 plus 2 is 4, 4 plus 1 is 5. So your A into A transpose is 5, 4, 4, 1. Similarly, you can find A transpose into A, 1, 2, 2, 1 is the A transpose into A, 1, 2, 2, 1. And if you see, it's a 5, 4, 4 and 5. Clear? Now, but I will tell you also, you can see this matrix is my symmetric matrix. Fine. Whenever the matrix is symmetric, then A into A transpose is equal to A transpose into A always. Fine. So you can write the matrix A is fine. This is the first step you have computed. Step number 2 is, your target is to find the eigens values of A into A transpose. Find A into A transpose. First matrix की eigen values निकालिए. How you can write that? I can write the characteristics equation. Fine. I can write there are the two methods to write the characteristics equation. The first method is, because it's a 2 cross 2, so that number is my lambda square minus the sum of the diagonal values called as a trace plus determinant of the matrix. So determinant of the matrix is 12 minus 16, that is my 9. Fine. Or you can write as a characteristics equation 5 minus lambda, 4, 5 minus lambda. Fine. So can you solve this determinant? So this determinant will be 5 minus lambda square minus 16 is 0. So that number will be 25 plus lambda square minus of 10 lambda minus 16, 0. And you can see the same answer obtained. So choice on your side. Fine. For more detail how you can find the characteristics equation, you can watch about my previous lectures. This is the 20 plus examples of the eigenvalue. That will teach you how you can solve in a very, very simple manner. Now, can you find the factor of this? Lambda square minus 9 lambda minus 1 lambda plus 9 is equal to 0. That will give you lambda minus 9, lambda minus 1 is 0. Therefore, lambda is my 9 and 1. Fine. Always remember, write the first number is the largest one. Fine. पहला नंबर सबसे बड़ी वाली लिखिए आप. Clear? Therefore, your singular values are, because there are two two lambdas, so we can find the sigma 1 and sigma 2. What is the formula for the singular value is positive root of the lambda I. So can you find the positive square root of the 9? 3. Can you find the positive root of 1? 1. Hence, your matrix sigma will be my, because again it's a 2 cross 2, these sigmas are my diagonal entries, rest values are my 0. So that number is my sigma is 3011. Fine. Remember, your target is always to write in this form. So we computed the value of the sigma. Now let's start with finding the value of the v. Fine. You can find the value of u as well. So how you can find the v? V is my normalized, is the normalized eigen vector of A ट्रांसपोज इंटू A. अगर आप यहाँ पे इंस्टेड ऑफ द V की जगह पे U लिखोगे, देन यू कैन फाइंड द नॉर्मलाइज्ड आइगन वेक्टर्स ऑफ A इंटू A ट्रांसपोज. आप इसको इस तरह से भी थोड़ा सा रिमेंबर रख सकते हो, बट दैट इज नॉट ए रूल, बट इफ यू वांट यू कैन रिमेंबर इट. आप V का निकाल रहे हो, देन इट्स V इज माई ट्रांसपोज. आपने दो मैट्रिक्स निकाली थी ना अभी तक, A इंटू A ट्रांसपोज. फाइन. तो यहाँ पे आप ट्रांसपोज वाली वैल्यू निकाल दो, तो स्टार्ट वो वैल्यू लीजिए जिसपे स्टार्टिंग में ट्रांसपोज है. फाइन. अगर आप यू निकालोगे तो यू के ऊपर आप देखिए कोई ट्रांसपोज नहीं है. फाइन. तो इन दोनों में से वो वैल्यू लीजिए जो स्टार्टिंग हो रही है विदाउट ट्रांसपोज, दैट इज ए इंटू ए ट्रांसपोज. फाइन. देन हाउ यू कैन फाइंड दी, अगर मैं इसी एग्जाम्पल में यू से ही कर रहा हूं, हाउ यू कैन फाइंड दी ए ट्रांसपोज ए? वी कैन फाइंड दी आइगन वेक्टर्स ऑफ A into A transpose into A. So we can write is a 5 minus lambda, 4, 4, 5 minus lambda into x1, x2 is my 0. Fine. हमेशा याद रखिए, after solving this equation you will get x1, you will get x2, but make sure both value can never be 0 at the same time. Fine. Both value must, एक वैल्यू 0 हो सकती है, एक वैल्यू 3 हो सकती है. फाइन. ये वैल्यू -1 हो सकती है, ये 4 हो सकती है, लेकिन ये दोनों कभी 0 नहीं होंगे. इज इट ओके? नाउ लेट्स स्टार्ट विद दिस. सो सबसे पहले हम निकालते हैं आइगन वेक्टर कॉरस्पॉन्डिंग टू, पहली आइगन वैल्यू क्या है आपकी 9. सो फर्स्ट आइगन वैल्यू कॉरस्पॉन्डिंग टू 9. आई कैन सब्स्टिट्यूट द वैल्यू ऑफ द लैम्डा इज इक्वल टू 9 इन द इक्वेशन नंबर 1. दैट नंबर इज -4, 4, 4, -4 into x1, x2. Right hand side is 0. Fine. Now how you can find the eigenvectors? Again, you must watch about my previous lectures related to the eigenvalue. I already explained you how you can find the eigenvectors in a very simple manner. So क्या बताया था मैंने? आप लास्ट वाली इक्वेशन को छोड़ दीजिए, बाकी क्या बच गया आपका -4 पहली रकम x1 के साथ और सेकेंड इक्वेशन सेकेंड वैल्यू x2 के साथ. फाइंड द वैल्यू ऑफ द x1 एंड x2. इसमें से x1 की वैल्यू कितनी आ गई? Which is my x2. Fine. इसको आप k के इक्वल लिख लीजिए. Therefore, eigen vector is, fine. आइगन वेक्टर आपका क्या है? x1, x2. तो x1 की वैल्यू कितनी है? k. x2 is also my k. So you can choose any value of the k. Make sure आप k को 0 नहीं ले सकते, because if k will be 0, then both the numbers are 0, which is not possible. So you can choose any value of the k. I can choose the smallest value is 1 and 1. Fine. So the eigenvalue is my 1, eigenvector is my 1, 1. But my target is to find the normalized eigenvector. So because मैं v निकाल रहा हूँ, so I call as v1. So the first vector is 1 and 1. Fine. You can divide it by its normalized value. So 1 square plus 1 square means अगर आपके पास वैल्यू है a, b and c, so the normalized is root of a square plus b square plus c square and so on. तो यहाँ पे दो ही नंबर है, so 1 plus 1 is root 2. I can write this number is 1 by root 2, 1 by root 2. Fine. Similarly, I can substitute lambda is equal to 1 in equation number 1. I can find the eigenvector corresponding to lambda is equal to 1. Again, I can delete the last equations. So you will get 4x1, 4x2 is equal to 0, which implies x1 is equal to minus x2. I can write this number is my k. Therefore, the eigenvector is x1 is my k, x2 is my minus of k. So you can choose any value of the k. So better I can choose as a k is 1, then this number is my minus 1. Fine. So the normalized eigenvalue is I can divide by 1 square plus minus 1 square, that is a root 2. Hence, v1 and v2 you have computed. So the value of the capital V matrix is the first column, this is my first column, V2 is my second column. क्लियर? अब मैं आपको एक तरीका बताता हूं कि आप चेक कैसे करोगे एग्जामिनेशन में वेदर योर आंसर विच यू हैव कंप्यूटेड द V is correct or wrong. Fine, how you can check? So that's very simple. You can multiply the first value with the first, it is 1/2, plus second value with the second, it is -1/2. अगर इसका आंसर 0 आ गया then this value is my correct answer. अगर ये वैल्यू 0 नहीं आई then this is a wrong answer. Fine. How you can check your answer in the examination whether V is correct or wrong? You can multiply the first row with the first, second with the second and check whether it's a 0 or not. और ये हमेशा 0 आना चाहिए. Clear? Now the V is also computed. Remember your target is fine. Sigma we already computed. V we already computed. Now your target is to find the value of U. So by using the definitions, you can find the value of the U is 1/sigma I A of Vi. Fine. That means U1 and U2. For this case, we can compute the value of A into V firstly. What is my A? 1, 2, 2 and 1. What is my V? V we have computed. So I can write A into V. So what is the answer? If you multiply them, there is a 1 plus 2 is a 3/√2. 2 plus 1, 3 divided by √2. 1 minus of -1/√2. 2 minus 1 is a 1/√2. Fine. So therefore, what is the sigma 1? Sigma is my positive root of lambda. ठीक है? So it's a 1/3. A of V1 is my first column. First column. So that number is 3 and 3 will be cancelled. 1/√2. 1/√2. Similarly, sigma 2 is my 1. Fine. It's a second column. This number is my second column. So that is my again -1/√2, 1/√2. Now once we know the U1 and U2, therefore the matrix U will be, I can write the first column U1 here and the second column is U2. Again you can check your answer in the examination whether U is my correct or wrong. Again you can multiply the first row with the first, we can multiply the first row individually. It's a -1/2. Second is, and if you add them, it must be 0. Fine. So therefore, we can write the single value decomposition is U, sigma and V. Finally, again, if you want to check your answer in the examination, what you can do? You can multiply U, sigma and the V transpose and see whether again the matrix A will appears or not. चलिए अब सेकंड एग्जांपल पे करते हैं. उम्मीद करता हूं यू कैन लाइक एंड कमेंट ऑन द वीडियोस. चलिए इस सिंगुलर वैल्यू ऑफ डिकम्पोजिशन निकालना आपको. सो फर्स्टली योर टारगेट इज टू फाइंड A into A transpose and A transpose into A. Make sure this matrix is not symmetric. Fine. तो अगर ये symmetric नहीं है then A into A transpose is not equal to A transpose into A. Like in the previous example, this matrix was symmetric and we have seen A transpose, A into A transpose are same. So let's quickly find that. -4, -7, 1, 4. What is the A transpose? -4, -7, 1 into 4. So quickly do that. 16 plus 49. So 65. -4, -28, -32. -4, -28, -32, 1 and 16. That is 17. Similarly, you can find the A transpose. -4, -7, 1 into 4. -4, -7, 1 into 4. So do it quickly. It's a -4. It's a 16 plus 1, 17. 28 plus 4, 32. 28 plus 4, 32. 49 and 16, 65. Fine. So we can see both the values are not same. Or again, you can see the sum of the matrix, sum of the diagonal values, sum of the diagonal values must be same. Now step number 2 is we can find the eigens values of A into A transpose. We can write the characteristics equations of A into A transpose. That number is lambda square minus sum of the matrix, sum of the diagonal values, plus determinant of the matrix. So determinant will be 65 minus 32 square. So if you solve them, you will get 81. So can you factor them? Minus 81 lambda minus 1 lambda plus 81 is 0, which implies lambda minus 81, lambda minus 1 is 0. Hence, lambda is 81 and 1. What is the singular values? So singular value sigma 1 is my positive root, sigma 2 is my positive root of lambda 2. Hence, sigma will be, I can write these are the diagonal values, rest numbers are my 0. Now, in the last example, I have computed as a V. Find per choice on your side. Find आप U को find करिए चाहे V को करिए, choice आपकी. तो मैं second example में आपको U दिखा रहा हूँ निकाल के. Fine. तो U के लिए आपको क्या करना होगा? यही है ना आपका टारगेट. तो U के ऊपर ट्रांसपोज तो नहीं ना लिखा हुआ. तो इन दोनों में से कौन सी ऐसी मैट्रिक्स है जिसपे स्टार्टिंग में ट्रांसपोज नहीं लिखा? That is A into A transpose. So I can start with the eigen vectors of the A transpose. कितना आएगा इसका eigen vector? 65 minus lambda minus 32 minus 32 17 minus lambda into x1 x2 is 0. Fine. So पहले 81 fill करते हैं. Substitute the value of the 81 in the equation number 1. You will get these two equations. Again, I can delete the last line. It's a minus 16x1 minus 32x2 is equal to 0. तो यहाँ से x1 की वैल्यू कितनी आ गई? x1 will be minus of 2x2. Fine. And I called this number to be my k. Is it okay? Is it okay? So therefore, the eigen vector is x1 की वैल्यू कितनी है? k. x2 will be, यहाँ से x2 निकाल लो, it is minus k over 2. Fine. अब आप k की कोई मर्जी की वैल्यू लीजिए. अगर मैं k को 1 ले रहा हूं, then this number will be 1 minus 1 over 2. Fine. और अगर मैं k को 2 ले रहा हूं, then this number will be 2 and minus 1. Fine. Or if I choose k is equal to minus of 2, then this number will be minus of 2 and this number will be 1. अगर मैं k को 3 ले रहा हूं, then this number will be 3 minus 3 over 2 and so on. So choice on your side. But my suggestion always avoid the fraction terms. Avoid the fraction term. Fine. And you can choose any number in between them. Choice on your side. Fine. So let's say I can choose k is equal to minus of 2. Fine. So my eigenvector is minus 2, 1. Therefore, normalized eigenvector. तो इसको किससे डिवाइड करोगे आप? Positive square root of minus 2 square is 4, 1 square is 1. So that is a 5. Minus 2 over root 5, 1 over root 5. Similarly, I can substitute lambda is equal to 1 in the equation number 1. You will get the equation is 64 minus 32 and so on. Again, I can delete the last line. 64x1 minus 32x2 is equal to 0. That gives you 2x1 is equal to x2. I call this number is my k. Therefore, eigen vector x1. तो यहाँ से x1 की वैल्यू कितनी आ गई? k over 2. x2 is my k. So you can choose any value of the k. Let's say k will be 2, then 1 and 2. So normalized eigenvector. तो वो किससे डिवाइड हो जाएगा ये? 1 and 4, that is 5 and 2 by root 5. Fine. And that number is my u2. Once we know the u1 and u2, and you can see. Again, you can check your answer whether this answer is correct or wrong. You can multiply them. It is minus 2 over 5. You can multiply the second number and you can see the addition will be my 0. That means yes, u is the correct answer. Now, you can find the value of the v. Find in the previous example how you can find the value of the ui, which is 1 over sigma I a into vi. Fine. लेकिन यहाँ पे हम our target is to find the v. So instead of the a, I can use as a A transpose. That means your v1 will be 1 over sigma 1 A transpose of u1. u1 is my first column. Fine. Similarly, V2 is 1 over sigma 2 A transpose into U2. So I can find the value of the A transpose into U firstly. This is my A. I can find the A transpose. This is my U. I can substitute the value A transpose into U. कितना आंसर आ गया बच्चों? क्विकली से करिए. +8 + 1 9 over √5. 14 + 4 18 by √5. -4 -4 and plus of 2, that's a minus of 2 √5, and the last number is -7 + 5, that is a 1 over √5. Then what is the 1 over sigma 1 is 1 over 9. A, that is the first column, and 18 by √5. So I can divide it by 9. So that number will be 1 over √5, 2 over √5. And what is the sigma 2? Sigma 2 is my 1. Fine. So that is the only second column. Hence, V value will be the first column V1, second column V2. Again, you can check your answer whether your answer is correct or wrong. You can multiply them. It's a -2 over 5 plus 2 over 5. That is a 0. Yes, V is my correct answer. Hence, we can write the single value decomposition is U, sigma and V. Look at the next example. Write the single value decomposition of 3, 0, 4 and 5. Again, you can see this matrix is my not symmetric. Fine. So once we compute the A into A transpose, they are not equal to A transpose into A. So I think that you can easily find that. What is the A into A transpose? 3, 4, 5, 0. Then 3, 0, 4 and 5. So what is the answer is 9. It's a 12. It's a 12, 16 and 25. That is my 41. Similarly, we can find the A transpose into A. That is 3, 0, 4, 5. So it will be, first number is 9 plus 16, 25, 0, 40, 20, 0, 20, 0, 25. Fine. Now how you can check whether your answer is correct or wrong? You can see the sum of the diagonal values is a 50. Sum of the diagonal values 50. These are the correct answers. Fine. Now step number 2 is we can find the eigens. We can find the eigenvalues of A into A transpose. So can you write the characteristics equation? Lambda square, sum of the diagonal values 50 plus determinants 9 into 41 minus 12 into 12. Fine. So that will be 30 minus 144. So which is 5, 2 and 2, 225. That is my characteristics equations. Fine. How you can find the factors? You can write this number is my 45 and 5. Fine. Or instead of them, you can write as a minus b plus minus b square minus 4ac divided by 2 into a. Choice on your side. So if you solve them, you will get lambda minus 45. Lambda minus 5 is 0. That means lambdas are my 45 and 5. Fine. So can you find the singular value? Sigma 1 root 45. Sigma 2 is root 5. So therefore, sigma will be root 45 and root 5. Then step number 3, we can find as a V. V is my eigens vector of A transpose into A. That is a normalized eigenvectors. So we can start from the A transpose A. I can write the eigenvector equations. Then let's start with the lambda is equal to 45. Eigenvector corresponding to lambda is equal to 45. Substitute in equation number 1. You will get as a minus 20, 20, 20, minus 20 into x1, x2. Fine. I can delete the last line, which implies 20x1 plus 20x2 is equal to 0. If you solve them, you will get x1 is equal to x2. I call this matrix is my K. बच्चों ये वाला lecture मस्त सुनिए, 20 plus examples of the eigenvalues. This will lecture clear you how you can find the eigenvalue and the eigenvector in a very, very simple manner. Therefore, the eigenvector is x1 K, x2 is my K. I can substitute K is my any number, let's say 1 and 1. Fine. What is the normalized eigenvector? So I can divide it by root of 1 square plus 1 square, that is root of 2. 1 by root 2, I can divide by 1 by root 2 and 1 by root 2. Similarly, I can substitute lambda is equal to 5 in the equation number 1. You will get the second equation. I can delete that. You will get 20x1, 20x2 is 0, which implies x1 is equal to minus x2. I call this number is my K. Therefore, eigenvector will be x1 is my K, x2 is my minus of K. K I can choose any number apart from the 0. So it's a minus 1 and plus 1. Fine. Or you can choose a choice on your side. You can choose K is my minus 1. Then it's a minus 1 and plus 1. दोनों में से कोई भी लीजिए, there is no issue about the calculation part. Hence the normalized eigenvector is minus 1 by root 2, 1 by root 2. Once we know the v1 and v2 both, therefore my target, my v vector is, and again you can check your answer whether this answer is correct or wrong. You can multiply them, minus 1 over 2 plus 1 over 2, which is 0. Satisfied? Yes, your v is correct. How you can find the u? So I can use the equations 1 over sigma I a into vi. Fine. We know the value of the sigma, we know the value of the a, and then we can multiply with the matrix. So a is my 3, 4, 0 and 5. I can multiply the v. Fine. And then what is the answer? If you multiply them, 3 divided by root 2 plus 0 minus 3 divided by root 2 plus 0, 4 plus 9 by root 2, 4 minus 4 plus 5, 1 over root 2. So I can substitute, it's a 1 over root 45. Root 45 I can also written as 3 root 5. Fine, it's a 1 over 3 root 5. First column of the matrix, 3 divided by root 2, 9 divided by root 2. That becomes 3 and 3 will be cancelled, 1 over root 10 and 3 over root 10. Similarly for the second, it is 1 over root 5 into minus 3 by root 2 and 1 over root 2. So if you multiply them, root 5 into root 2 is a 1 over root 10 and it's a 1 over, sorry, minus 3 over root 10 and 1 over root 10. So therefore your matrix U will be, you can write the first column as U1 and second column as the U2. Again you can check your answer. You can see minus 3 over 10 and plus 3 over 10, which is 0. Satisfied? Yes, your matrix U is correctly defined. Fine. Now I have solved a few questions for you. The rest question you can do it by yourself and let me know in the answer whether you are able to understand the concept of solving these problems or not. The next question is, now you can see it's a 3 cross 2 matrix. Fine, it's a 3 cross 2, but whatever we have discussed here is my n cross n matrix. But how you can write the single value decompositions of the matrix A for the non-square matrix, that is called as rectangular matrix? How you can write the single value decompositions? For that we will see the next lecture how you can write the single value decompositions for M cross N matrix. Let me know in the comment box, are you interested to watch the next lectures? Till then you can share this video, you can like and comment on this video. Happy learning always. Best wishes for your future's work. Thanks for the watching.